Hi. Hello. Hello. Okay. Hope everything's going all right. Uh, so we're just going to start getting you guys onto the next worksheet for today. It's kind of over the forces that we were talking about last week. This one's we're just going to sort of concentrate on um, friction, the frictional force. So we'll go over friction again quickly, and then do some practice problems, and then hopefully you'll be ready for the worksheet. Um, so if everyone's ready. I guess I should present. All right. So I am going to give a quick explanation of what I spent more time last class talking about with regard to friction. Uh, we had, if you recall, two different scenarios when we're dealing with friction. There was the kinetic case where something is moving and there's friction resisting that movement. And the other was static friction, where the thing is not moving, but friction is acting on it to keep it from beginning to move. So we had the kinetic case and we had the static case. The important thing to remember with the static case is that the formula for calculating static friction versus kinetic friction look very similar, but they're used in very different ways. So in the kinetic case, when the object is moving, the model that we have for simple friction is that the force of friction doesn't change unless the motion is changing. That for long as the thing is moving, the friction will resist that movement with a constant force against the direction that the object is moving in. And if it's not strong enough, the object won't stop. If it's strong enough, it will eventually bring the object to a stop, if it can overcome other forces that are driving it. That was the kinetic case. So it's a constant force, basically. So you just use the formula and you calculate that force, and that's how much friction is pushing on the object. The static case, if you remember, the formula could be used, but it told you the maximum amount of pushback the object can give you before it breaks, before it starts moving. So in reality, the amount that you push is the amount that friction pushes back when you're not successful in moving something. The formula doesn't give you the amount of friction. It matches the applied push. Do you recall that, and is that okay? Okay. So I just have some example problems that we can go through to make sure that you are ready for the assignment, and that's pretty much it. So we will go through those. I've just shared them. So you should see some friction worksheets down here. One of them comes with some answers at the bottom. They're just answers. So you could try some of those and see if you're getting them right. And then you'll know that you're doing them right if you get the same answers. Otherwise, it'll tell you that you're not doing them right if you don't get the same answers. Usually, that's what that means. And then one of these will be, I think the second one, will be homework. And we'll have the other one for practice as well. All right, so I might start with the last one, actually. And this one has pictures, which is nice. So let's see. Nope. Hopefully you can see that. The first question is about a force of 42 newtons is needed to start a box sliding across the floor. The weight of the box is 55 newtons. Draw all the forces acting on the box. So first they want us to come over here and draw on it. I can do that on Inkscape. Oops. So I'll just draw a line. We'll have a box. That can be the box. And we need to draw forces. So anybody know what are some forces I should draw in my box here? Anybody got any ideas? Do you remember do you have some of the drawings that we did last class maybe?
You could do a downward arrow of 55 newtons.
Good, good. Did it say that's the weight of it? Or did it say that was kilograms?
It said the weight of the box is 55 newtons.
Okay, good. Well, that's good. Oh, I hate when it does this. This stupid arrowhead. There. Oops. Maybe like that. Maybe half of that. So 55 newtons. Whatever. Okay. Any other forces that we could add to this? Do you have some of our drawings from before?
Applied force?
Okay, yeah. There was. Do we have an applied force yet in the problem? I keep alt tabbing. Let me see. Okay. So yeah, I guess we'll draw the 42. What I wanted to do. There we go. I'll make it a little shorter. So that's a 42 applied. I'll just assume it's to the right. Anything else? Maybe one more.
Is there an upward arrow of 55?
Yeah, there is, yeah. So that's the normal force from the ground, keeping it from falling into the ground. Yeah, so we got the normal force, the gravitational force, the weight, an applied force, and when they said that it takes a 42 Newton force to get this thing to start moving, what that means is that that's the maximum threshold. That the frictional force can push back anything after that, and it's broken. So I think that's good.